Okay. Can you hear me? I'll try to talk very softly. Because I could actually talk to this room without the microphone. So, the good news is I'm the last presenter. The bad news is I'm the last presenter. When they first did this agenda, I was actually way up at the beginning, right after John Zanos and Callista. And then they came to their senses. So, I'm the chair of the Technical Steering Committee. And what they asked me to do is give you an update on some of the work groups and things that we've accomplished this year. If you were at the summit in San Jose, you may be bored, but we'll do what we can. So I want to talk a little bit, take you through a few key things. We have a number of CAPI-related specs that were released over the year. We did some stuff around the power processor architecture. And in conjunction with the System Software Work Group, or primarily through the System Software Work Group, we updated a completely new document infrastructure. There's a resource catalog that you can get all this material from. There's a spec that is being developed through the Memory Work Group. I'll talk a little bit about that. And then I'm going to talk a little bit about some new work groups that we're doing. And I'm going to try to do that all within less than 15 minutes so you can all get to the drinks. Okay, so within CAPI, there's actually two specifications. If you ignore the new snap stuff you just heard, there's two specifications. One is a software level specification that's kind of an interface between the ISA and the software application. That's called CAIA. And the other is the interface that talks down to the actual accelerator. That's the timing diagram that Bruce showed earlier, the bits and bytes of it. Those two specifications have been completed and approved, and they are released for public consumption and available on the resource catalog. Within the architecture part of things, we have a hardware architecture work group and a system software work group. And there's several specifications that are available, again, through the resource catalog. The first one is an ISA profile that talks about specific parts of the Power ISA 2.07 subset that's important for OpenPOWER. Boring, right? It's a small document. There's an I/O device architecture document that talks about important things like how the software views the PCIe host bridge. Dull, right? But that's the kind of thing we're doing as part of OpenPOWER, is to make those specifications available so people who develop applications and develop new hardware solutions can be compatible. I already talked about the CAIA, and within the software work group, the most important thing that we're in the process of releasing right now is this little endian ABI application, 64-bit little endian ABI ELF. That's its full name. Doesn't matter what it says up there. It's been published through the System Software Work Group, and now they're working on the next generation of it that'll talk to or describe what's going on with P9. So that's important work there. And then I think there's a informal working session tomorrow morning if anybody's interested in being part of it. So I mentioned that we have a framework for OpenPOWER Documents. Basically what it is rather than doing everything with Word or with FrameMaker or some proprietary solution, we went out to the open source community and looked for what are people doing for document development, and we actually borrowed a lot of this from OpenStack, using DocBook, which is XML tags. It's all built around a GitHub repository so that all the work groups can work together to collaborate on their documents. And when you generate the document, when you're done, you get two forms. You get a web-based view shown over on the left, and you can also get a PDF version. they end up looking like really professional, really nice looking documents, and by doing it with DocBook, it makes it easy for us to go in and update the look and feel to make sure that everything is consistent and compliant with the standards for the organization. So we really think that's a great thing to do. There is a developer, for those of you that care, there is a document development guide. This is actually the screenshots for it. And of course, it's available on the resource catalog, which is, perfect. So out on the OpenPOWER website, there is a link that leads to this resource catalog. Basically, it's a very generalized database, if you will, for materials that we want to distribute, and it's used for distributing specifications, but also product information and solution information of things that anything that people want to share within the community can actually be added into that. And it's searchable, and if you do a nice job, if we do a nice job on the entries for each one, it actually gets searched well by Google and Yahoo. I mentioned the OpenPOWER Memory Bus specification. This is a specification that is in development within the memory work group. We have just got it to the stage where we think people could actually implement memory function units based on it. So if you're interested in that, you actually need to join the memory work group to get at it. But the idea here is, on this side is the host processor with Power 8. That's currently DMI. When we get to Power 9, you'll see OpenCAPI on that side. And what we've done is we've defined this specification down the middle, so that the actual talking back to the host, the bits and bytes of that is abstracted away. This interface it's now possible to put a abstract memory function unit designed to that interface, so that you can conveniently integrate new and different memory technologies. I think there's a demo, or there was a mention of the work that Adam McPadden had done on, I can't remember what it was earlier today, where they showed a new memory technology that was actually integrated into a power system. That's not an implementation of this, so don't be confused. That's an early implementation that IBM did to enable that kind of activity, and this work is a bridge from that. So this is kind of our open sourcing of that work. And so there's some other work groups. Callista mentioned there's 12. I'm not going to go through all 12. There's a few others that are of important that we'd certainly like people to get involved in, because we think they're important to making the foundation go. Compliance work group, 25 gig interoperability mode work group, which is really down at the electronic or this physical signaling level for those open interfaces that are coming off of P9. Personalized medicine work group. We have one called the FSI specification work group, and that's about a service interface. And then we have a much broader work group called the I/O work group, which is all about enabling adapter integration into OpenPOWER systems, and porting guidelines and test suites and that kind of stuff for making it possible to integrate I/O, more robust I/O adapters. And then lastly, we have two new work groups. The top one is OpenPOWER Work Group for Physical Sciences. That was just recently formed. The chair is Andre Bulgarelli. I'm sure I butchered that, Andre. And it's really talking about identifying and describing use cases and common workflows within the scientific and experimental communities. Okay? And then the last one is the OpenPOWER Ready work group. That work group was set up to manage the OpenPOWER Ready definition and criteria document, and look into the establishment of a Plugfest where we can get together and show compatibility for various solutions. We haven't actually had our kickoff meeting for that yet, so we don't have a chair, but that'll be happening shortly. If any of you are interested in being part of any of those work groups, you just go out to the, if you're a member, you have to be a member of the OpenPOWER Foundation to actually be part of these work groups, with the exception of the the work group for physical sciences. That one is actually open to the public, so you'll need to get directly in touch with Andre to do that. But if you're a member of the OpenPOWER Foundation, you can go out and join one of these work groups and be very active in the development of these, and I should say the enhancement of the specifications we have here, as well as new projects that we're putting in place. For example, within the accelerator work group, the SNAP environment came out of that work group, and we're going to be doing more of that. So I think that's it. Did I